So we come to tricks associated with balancing a redox reaction of type B. To understand type B, as we go to the first question, you will be able to understand what is a type B question and how you are supposed to balance it. Now, if you check, oxidation number of nitrogen is -3, nitrogen is -3, and nitrogen is 0. That means nitrogen's oxidation state remains same in one of the product. At the other place, it is changing. When you have one of the reactants, having a product where oxidation state remains same in one case and oxidation state is changing at the other place, that type of a question is called as type B. In such type of questions, always write down the same reactant 2 times. So if you see the second, in this case we have written same ammonia 2 times. And what we do is we correlate this ammonia and its balancing with this part where oxidation state remains same. Oxidation state of nitrogen, if you know, it's -3 and -3. This is same. And balancing of this ammonia will be associated with this nitrogen's balancing. So nitrogen oxidation state is -3 and 0. So remember, this balancing of the pink colored box substance and the balancing of pink colored box substance at this place are associated with each other, and the balancing of green color box and the green color box is associated. And even chlorine's balancing, if I show it with a different color, chlorine's balancing is associated with chlorine's balancing. Are you understanding it? So type B questions are slightly differently solved. We go back how we analyze type A. Similarly, we are trying to analyze this also. 0, chlorine is going to -1. So chlorine is undergoing reduction and ammonia is undergoing oxidation. So it is an example where nitrogen is undergoing oxidation and chlorine is undergoing reduction. This is what is a typical redox reaction. If you write down the oxidation state and the changes, nitrogen going from -3 to 0. So the change is by 3 for one nitrogen. But we are looking at ammonia, which has only one nitrogen, so change is 3 only. Chlorine is going from 0 to -1. 0 to -1, so change is by 1 for one chlorine. But we are looking at a chlorine molecule which is made up of 2 chlorine atoms, so change is 2. If you remember, what we do next? We cross multiply this number with this number with this. So ammonia's number will be 2. So remember, ammonia's number will be 2. And chlorine's number will be 3. I'll call this as a substance with changing oxidation state. I'll call this also with changing oxidation state. I'll call this as nitrogen unchanged. Unchanged nitrogen. This also nitrogen as unchanged nitrogen. Remember, unchanged nitrogen. The balancing of these two are associated with each other. Remember, and balancing of this two is associated with each other. So now we are seeing the balancing associated with this. How many nitrogen are present here? 2. So how many nitrogen should be present in the similar pink color box on the other side? It should be 2 nitrogen only. So if you check, if you put by putting 1, it's 2 nitrogen only. So nitrogen is balanced. I'll call it as changing nitrogen balanced. Changing nitrogen balanced. Okay, coming to the next one. Chlorine. How many chlorine are there here? 6. So how many chlorine should be present here? It should be 6 only. So even changing chlorine is balanced. Changing chlorine means chlorine whose oxidation number is changed. That is, we are saying changing chlorine. We are giving some name. So 6 chlorine. This is balanced. Now if you check, this number has come, this number has come, this number has come, and this number has come. Now from where can we get this number? You should remember this is unchanged nitrogen. And in this case also unchanged nitrogen is there. So from this only you can get that. From this only. So how many nitrogen are present here? 6. So number of nitrogen here also should be 6. Now everywhere we got the number. Now we write down collectively. So how many ammonia are there? 8. How many chlorine are there? 3. How many ammonium chloride? 6. And how many nitrogen? 1. And if you check and verify, you will realize the reaction is balanced. So what was the trick of balancing it? That ammonia was written in 2 times. Why ammonia was written 2 times? Because ammonia or nitrogen associated was having one compound with same oxidation state and the other with different oxidation state. With changing oxidation state was shown with pink and unchanged was shown with green. Unchanged was shown with green. Remember this balancing was associated with this balancing. Remember, while this balancing was associated with this balancing. Remember that. So they were associated. One more example will help you to understand this better. Second example, copper with nitric acid. If you see copper, you'll know copper has oxidation state of 0 and copper is going to +2. That means copper is getting oxidized. Nitric acid, nitrogen is +5. In this case also nitrogen is +5. Remember why? Because both of them are nitrate ions only. In a nitrate ion, nitrogen's oxidation state will remain same. In this case, nitrogen is +2. So what you are able to see, nitrogen, in one case, its oxidation state remains same. In the other case, nitrogen's oxidation state is changing. That means nitric acid has 2 products. So what we do, we write down nitric acid 2 times. Are you able to see? Nitric acid 2 times. Now what next? What we do, we fix up this nitric acid with this nitric acid. And I'll call it as unchanged nitrogen. Why unchanged nitrogen? Because oxidation state of nitrogen in both the cases is same. I'll call it as unchanged nitrogen. And I'll put a mark here also. And I'll put a mark here also. What is this? I'll call it as changing oxidation state of nitrogen. I'll just simply write on changing nitrogen. Remember, changing nitrogen means nitrogen whose oxidation state is changing. Copper is also changing. Remember that. Okay. So these 2 balancing are associated and these 2 balancing are associated. Remember that. And who decides the numbers? Only changing. So only these 2 will decide the number. So we go back. Our traditional method. Copper is going from 0 to +2. That means copper is changing by 2. And nitrogen is going from +5 to +2, changing by 3 for 1 nitrogen. But we are looking at nitric acid. So 3. What we do next? We cross multiply this number here, this number here. But this cross multiplication should be done only with changing. So number with copper will be 3 and number with changing nitric acid should be 2. Now this number of copper should be balanced here also. So it should be how much? 3. And this number of nitrogen should be balanced here. So number of nitrogen is 2. So number of nitrogen is 2. So balanced. Now this balancing is left. This is left. This will be dependent on this only. How many nitrogen are there? 3 multiplied by 2, that means 6. So it should be 6 nitrogen. 6 nitrogen. What next? We write down them together because it's actually nitric acid only. Are we allowed to write down nitric acid 2 times? Yes, because you're not changing the reactants. This reactant previously was copper plus nitric acid. Reactant now also is copper plus nitric acid. In this case also the reactants are same. We are not changing reactants, so we are allowed to write on nitric acid 2 times. So what is the final balancing? Final balancing will be 3 here and 8 here. And already we got the number here 3 and we already got the number here 2. Only number which is left is with water, which can be easily done based on hydrogen. 8 hydrogen, so there should be 8 hydrogen. And if you check, you'll realize this reaction is balanced. What was the trick? Nitric acid had nitrogen with one same oxidation state, and the other with changing oxidation state. One with same, other with changing. So what we did, we wrote reactant 2 times, not products, reactant 2 times. And then we accordingly correlated. Now if you have understood third one, you should be able to do it on your own. You can pause this video and try the third one on your own. I suppose all of you should have tried. So copper is going from 0 to +2, changes by 2. Nitrogen is going from +5 to +5 and +4. What you are able to see? This place oxidation state is same, and at this place oxidation number is changed. So changed and same. So what we do? We write down nitric acid 2 times. You got this? And we correlate. Imagine we correlate this with this. What is this? I can call it as unchanged nitrogen. What do you mean by unchanged nitrogen? Where oxidation state of nitrogen remains same. +5 +5. Remember, this balancing and this balancing goes together. What I can call this? I can call it as changing nitrogen. And whichever we have put into orange color box, their balancing will match. Changing nitrogen. Changing nitrogen. What do you mean by changing nitrogen? Whose oxidation number is changing. In this case, nitrogen is going from +5 to +4, changes by 1. What we do next? You already know what we do. We cross multiply. This cross multiplication is done with which nitric acid? Shown with the orange color rectangular box or pink color rectangular box? Yes, you're correct. Orange color rectangular box. Why? Because that is changing. So what is the number with copper? Number with copper you got 1. What is the number with nitric acid for changing? 2. So if the copper is 1 at this place, copper should be 1 also here, because it's only one place copper is present. If nitrogen is 2 here, nitrogen should be also 2 here. We are counting the number of nitrogen, not stoichiometric coefficients. Now what next? We are left with this number. What is this number? This number, which is for unchanged nitrogen, depends on unchanged nitrogen. How many nitrogen are here? Yeah, correct. 2 nitrogen. So it should be 2 nitrogen. We know this together are nothing but nitric acid only. So we almost got our entire reaction balance. 1 copper, 4 nitric acid, 1 copper nitrate and 2 NO2. What is left? Is balancing of water. But that's easy. How many hydrogen here? 4. So how many hydrogen should be here? 2. And this leads to our balancing of this reaction. So it is balanced. So that was balancing of type B reactions.